Hello everyone, we're looking at angles today. In our unit on proofs, we need to have more ideas that we can use to connect together to work out these proofs. So in the previous day of notes, we introduced ourselves to the two-column proof using some angles and some segments. Here we're stepping away from proofs for just a moment as we introduce some more types of angles, and then we'll be using these in proofs in the days to come. So let's start off with our vocabulary and put down some diagrams to describe what these might look like. First, let's talk about adjacent angles. So adjacent angles are two non-overlapping angles that share a common vertex and side. So just remember that when we're talking about an angle, the vertex is where the two sides come together at a point. Right? So we want two non-overlapping angles that share a common vertex and side. So let's diagram this out. Here we have my first angle, and we want to draw our second angle in such a way that it shares a common side and a common vertex. So here is my second angle, sharing the common side and sharing the common vertex. So they all have the common vertex there. So I could number them something like this. So we could say angle 1 and angle 2 are adjacent angles. So let's give some examples that are not adjacent. If they're not adjacent, then that means they either cannot share a common vertex or they cannot share a common side, or both. So here's one, and for this first diagram, I'm going to make them overlap. And so to make them a little better to be viewed, I'm going to use two different colors here, and that way you can see what angles we're looking at here. Alright. They don't have to be the same size, but just to color coordinate them, you can see that they do have a common vertex, but they don't have a common side. And they're overlapping. They're not supposed to be that, so that would be not adjacent. Here's another diagram to consider. There's angle 1, and here's angle 2. Notice in this pattern, they do have a common vertex, but they don't have a common side. There's this gap in between, in fact, a whole third angle. So these are not adjacent. Alright, so to be adjacent, it's more than just being next to each other. They literally have to have a common vertex and a common side. Here's another pair of angles to consider. We could have angles that are completely separate like this. Here, angle 1 and angle 2, they don't have a common vertex. They don't have a common side. And here's a last example to consider. Notice in this pattern, they do have a common side, but they don't have a common vertex. So all of those are not adjacent angles. Let's take a look at complementary angles. Complementary angles are two angles whose sum is 90 degrees. Alright, so when we draw our diagram for complementary angles, we have to draw an angle that's a 90-degree angle. And you remember that to do that, we always put that little box in the corner instead of the number 90 degrees. That tells us it's a 90-degree angle, that it's a right angle. And so we want two angles that add up to 90 degrees. So create another ray in there. And here we could say the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So this is my angle addition postulate. At one angle plus an adjacent angle makes for the bigger angle total, which happens to be 90 degrees. So there's a lot going on here. It's the angle addition postulate, and we have adjacent angles, and we have complementary angles. So that's why we call them complementary adjacent angles. What about if they were complementary but not adjacent angles? Well, that's easy enough. We're just going to pull them apart. So we could separate them and say there's angle 1, there's angle 2, and we can still say that the measure of angle 1 plus the measure of angle 2 equals 90 degrees if we want to insist that they are complementary, but they're not adjacent, but they are complementary. So for example, we could say that this one is 60 degrees and angle 2 is 30 degrees. And so if we were to substitute those numbers in, you'd have a 60 degree angle plus a 30 degree angle, and sure enough, that adds up to 90 degrees. That checks out. And lastly, we have supplementary angles. Supplementary angles are two angles whose sum is 180 degrees. I see in my previous definition I left out that word. For complementary angles, two angles whose sum is 90 degrees. Let me just fix that. Okay, so once again we have supplementary adjacent and supplementary non-adjacent. Now if we have two angles who sum up to 180 degrees, and start with drawing a 180 degree angle, and remember that a 180 degree angle is essentially a straight line. The sides of the angles have been spread so far out that they point in opposite directions. That's your 180 degree angle. So from the vertex we want to create two angles that are adjacent to each other like this. So as an example, maybe we use 120 degrees and 60 degrees. They add up to 180. So the measure of angle 1 plus the measure of angle 2 is 180 degrees. So there's a lot going on here again. We have adjacent angles. We have supplementary angles. This is our angle addition postulate, which means an angle plus an adjacent angle adds up to a bigger total. But there's another name for this, and this is also called a linear pair. And we'll be talking more about linear pair on the next day of notes. But this is a linear pair. A linear pair is a supplementary adjacent pair of angles. And a linear pair then is a pair that adds up to 180. So let's separate these two to create a pair of supplementary but non-adjacent. And we'll just pull them apart so we have a gap between the sides. So again, there's angle 1, there's angle 2. We can use the same angle measures to keep the example simple. You can see that those angles still add up to 180, but they are not adjacent. Alright, turn the page. So the first few examples are really just practicing these vocabulary words. Example 1, tell whether the indicated angles are adjacent. So we want to know, do the two angles share a common side? Do they share a common vertex? Yes, these are adjacent. Here in part B, this is one angle. This is a second angle. Notice they do share a common side, but they don't share a common vertex. But they are not adjacent. In part C, think about this diagram. Here we have angle J, N, M. So start with J, go to N, go to M. That's talking about these two sides. So this is the first angle, angle J, N, M. The second angle is angle L and K. So start with L, go to N, go to K. We're touching the sides on L and K. So we're talking about this angle here. What do you think? Are they adjacent? They are not adjacent, because they do have a common vertex, but they don't have a common side. Let's name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. Alright, so if I'm talking about a pair of complementary angles, they have to add up to 90 degrees. Well, that's not these two. That would definitely be more than 90. It's not these two. Again, that'd be more than 90. It has to be these two. So remember, when you are naming an angle, if you have an angle like this one, where you have only one angle at that vertex, you could just call it angle B. Or you can call it angle ABD. You can use the three-letter combination. Now, for its complement is over here, angle 38. We cannot just call it angle D because there's lots of angles at vertex D. We don't know which one you're talking about. So here we have to use the three-letter combination. So this angle then is angle CDB. And again, you can name that forwards or backwards. So with the angle that's just labeled as angle B, you can use a single letter, or if you want, you could use a three-letter combination of calling that angle ABD, forwards or backwards. A pair of supplementary angles then, we need to have two angles that add up to 180 degrees, and that will be these two, the 52 degree angle and the 128 degree angle. So again, we have angle B, and its supplement is over here. Again, you can't just call that angle D. We have too many angles that share a vertex at D. We need to use a three-letter combination. So angle B, D, E. Forwards or backwards is okay. And then we need some adjacent angles. Two angles that share a common side and a common vertex, and that'll be these two angles right here. So the 38 and the 128. So let's name this angle. This is angle CDB. And then its adjacent pair is this angle. This is angle BDE. Alright, so now we're going to the math part, our calculation part, as we're talking about setting up equations for complementary and supplementary angles. Alright, so example 3, angle 1 and angle 2 are complementary angles. So remember, complementary angles means that they will add up to 90 degrees. So we're told one of the two, we have to find the other. Alright, so what we want to do then is think about this. If we have the measure of angle 1 plus the measure of angle 2, we know they have to add up to 90 degrees. If the measure of angle 1 is 52 degrees, there's our substitution. And that means that angle 2 is our variable. That's what we want to solve for. So move all the numbers to the other side. We're going to subtract 52 degrees from both sides, and we get 38 degrees. Okay. I'll skip part B because that's just a different pair of angles. But let's think about the wording here in part C and part D on this same problem. So we know angle 1 is 52 degrees. We know angle 2 is 38 degrees. That's the pair we're working with. So what is the sum of angle 1 and angle 2? Right, sum means addition. So what would be the addition of those two? I hope you figured that out as 90 degrees. Yeah, because that's what complementary means. It means two angles that you add together to get 90 degrees. So really the twist here is, what is the difference of angle 1 and angle 2? So difference means subtraction. So if we were to do a subtraction problem like this, then all of a sudden that doesn't make 90 because we're not actually adding them up, are we? We're subtracting, right? So let's see, what do we get here as a result? 38, 48, 14, I believe. Double check my math on that one. Here in example 4, we have two angles that are now supplementary angles. So remember, supplementary means that they are going to add up to 180 degrees. And so here we have two angles that are adding up to 180. So again, we can think of this as the measure of angle 1 plus the measure of angle 2 adds up to 180. Do our substitution, plug in 72 degrees for the measure of angle 1. So that means the measure of angle 2 is our variable, and then we want to solve for that by subtracting away the 72. So 180 minus 72 gives us 108 degrees. So again, we'll skip part B here. And then on part C, sorry, there we go. So the measure of angle 2 is 108 degrees. So then on part C, what is the sum? So sum means addition. Well, if we were to add together these two angles, Double check, they better add up to 180. And what is the difference? The difference means subtraction. We'll take the bigger angle and subtract the smaller angle. We'll go in that direction. And the difference then is 36 degrees. Those are pretty basic when we're talking about sample problems for complementary and supplementary, because we're just using the numbers themselves. They get a little more involved on the next page now when we're talking about using expressions. So turn the page, let's take a look at this last set of examples here. We're still using complementary and supplementary angles, but you realize that instead of just a number, we have an expression. Here, the measure of angle x, the measure of angle A is just x degrees, while the measure of angle B is described as being a size of x minus 30 degrees. Alright, so we're talking about complementary angles. You don't have to draw a diagram here, but I will just for this instance so that we can see visually what that might be talking about. Remember, complementary angles are angles that have to add up to 90 degrees. You're drawing your right angle and then splitting that with angles of two different sizes. One of them is, the first one, x degrees, and then the other one is the x minus 30 degrees. So that's what a diagram could look like potentially. In terms of our equation, we can say the measure of angle A plus the measure of angle B equals 90. Because two angles are complementary, they add up to 90. Now we do our substitution. Angle A is the x, and angle B is the x minus 30. You'll notice I'm not using the degree symbol here, and that's because we're now going to be solving for x, and x is the variable. The variable doesn't need the degree symbol because the degree symbol is already provided on that variable. So let's combine like terms. X plus x is 2x, and then 2x, we're going to add 30 to both sides, and then we'll divide away the 2, and we get x equals 60. So we did find x, but that's not what the question is asking. The question specifically wants us to find the measure of angle A and the measure of angle B. So now we have to plug this information back in. So the measure of angle A is in fact just x. So my x is 60, so this is 60 degrees. The measure of angle B is represented by the x minus 30. So plug in our value of x and then subtract the 30, and we get 30 degrees. Now you should be able to check your work by adding together these two answers. Does 60 and 30 add up to 90 degrees? They sure do. We did our answer right. So you try part B, pause the video, work it out, and I'll just jot down the answers for you to check your work. Alright, so the answers are 44 degrees and 46 degrees. If you got that, you're doing great. If not, come and show me your work, and I'll guide you through the steps. Here in example 6, we now have A and B are angles that are supplementary. So again, let's find the angles both. You'll notice some of these say things like show all algebra work. That means no guessing and checking. Don't just run through combinations in your head. It means set up the problem, do the substitution, solve for x, and so forth. Now if we're talking about supplementary angles, and we were to draw a diagram, it could be something like this, where maybe that's the angle, that's the x degrees, and this is the bigger angle with the 3x degrees. So the measure of angle A plus the measure of angle B equals 180. That's our supplementary pair. Do the substitution, so the measure of angle A is x, the measure of angle B is 3x, and not much algebra here as we just combine like terms and get 4x equals 180, and then divide away the 4, we get 45. Again, no degree symbol because that's just the variable's value. Now we'll take that and plug it back in. So the measure of angle A is 45 degrees, and the measure of angle B is 3 times the value of x, and that'll give us 135 degrees. Alright, so once again you should be able to check your answers here, add them up. Do they add up to 180? Yes, they do, so we did our work just fine. Alright, so you try part B, set that up, work it out, and then check your answers when you're done. The measure of angle A is 158 degrees, the measure of angle B is 22. Here's our last diagram, and these are a little bit tricky in the sense that they're not telling us whether it's a complementary pair or a supplementary pair. We have to read that diagram and understand how to set up the equation. So let's look at part A. We do see a straight line. We do know that's going to be a total of 180 degrees if we added up all three of those angles. Or we can kind of ignore that right half and just use the left half because we happen to have perpendicular lines. If we have a right angle here, we'll also have a right angle here, and that makes a complementary pair. So we can recognize that the angle with the 2x degrees added with the angle with the 3x degrees will add up to 90 degrees. That's our complementary pair. So we get 5x equals 90, we get x equals 18, and again they want us to find those specific angles, so we have to plug that back in. So the measure of angle ABD, that's the first one is listed. ABD, that's the one with the 2x degrees. It's going to be 2 times the 18, and that gives us 36 degrees. The measure of angle DBC, that's the second one listed. DBC, that's the one with the 3x degrees. Going to be 3 times 18, and that gives us 54. So again, you can check your math, add those up, and they should add up to 90. So what do you think about this last one? What should we add these angles up to? It is a straight line. That means it's a linear pair. It's a supplementary pair. There's 180 degrees. So again, the number of degrees of that straight line is 180. So we should set up our problem like this. 4x plus 6 is the angle on the left. We'll add that to the 11x minus 6, that's the angle on the right, and that adds up to 180. Let's combine like terms. 4x plus 11x is 15x. 6 plus negative 6 cancels out, so that just turns into a 0 there. You don't have to write down the 0, but just to keep track of where those 6's went. Divide away the 15, and a little help with our calculator tells us that we have an answer of 12. Okay, so now let's plug 12 back in to get these two angles. So the measure of angle ABD is the 4x plus 6. So here's the 4 plus the value of x plus the 6. So that's my 4x plus 6, and that gives me a result of 54 degrees. The last angle, the measure of angle DBC, that's the 11x minus 6. So the 11 times the value of x minus 6. That gives us 126. So again, we can add those up to double check to see if in fact that adds up to 180. And they do. So we did that correctly.